So when we do the data mining on the multimedia database, we can also do something like the spatial relationship. So what is the spatial relationship? For example, the property P1 on top of property P2. Well, if it is on top of, it means, yeah, we want to see what is the top side of this image. What is the top side of this image? What is the top side of this image? Okay. Or we can see the property P1 next to property P2. So what is the next of this image? What is the next of this pixel or this image, and so on. So this kind of spatial relationship, usually, yeah, we have the in the land, the earth, usually they will figure out whether there is building beside of the river, or is there any building on top of the river, or is there any building on top of mountain. So those kind of, yeah, multimedia database, we can also extract it from the images or from the video. And yeah, of course, we can make in different resolution. It depends on the images, it depends on the video. Yeah, if you are going to do more about the multimedia database, you also need to figure out coarse fine. What does it mean by coarse and fine? Coarse is more about rough. So the figure might not be clear. Yeah. So you can see some like unclear figure like this one. If it is fine, fine is more like in detail. Yeah. Fine is more in detail resolution. So you can see, yeah, this kind of figure. So you can see that, okay, this is a lamp, this is a book, and there's a banana. But if it is coarse or rough figure like this one, you cannot identify what is the figure. So usually this kind of data or this kind of image, it has low resolution. And this kind of data, it has a high resolution. And yeah, it is good if we have this low and high resolution at the same and on all of the figures. But what if there are some figure like this one, it is coarse or it is blocked? If you see from the media, from the news, okay? So some of the pictures, if it is not good for public, they will block or they will make it blur. So it is difficult to get what is this object. Or maybe you can see this one is the title of the book. But here, the title of the book is broken. So this might be some challenges whenever you try to mine from the multimedia database. Or maybe you have a very small picture like this. This is also low resolution, or we call it, this is coarse resolution. And this is fine resolution because you can see clearly about the image. So, and so on. So there are many challenges whenever you do with the multimedia database. And the other challenges is the curse of dimensionality. Okay. You know, in our first part of the data pre-processing, we learn about the curse of dimensionality, and we can do to handle the curse of dimensionality with feature reduction. Okay. So whenever we have the curse of dimensionality in the image data, it is difficult to implement a data cube efficiently given a large number of dimensions, especially serious in the case of multimedia data cubes. And many of these attributes are set oriented instead of single value. You still remember what is it? Set oriented. In the first part of our lecture, we have the set value attribute. So if it is a set value attribute, it is more likely about this. We have one kind of category, and this is the single value attribute. So this is a set. So sports is a set of value such as tennis, hockey, and chess. So whenever you do with the multimedia database, we will also deal with this kind of set values, not with the single values. Okay. And restricting numbers of dimension may lead to the modeling of an image at a rather rough, limited, and imprecise. So if you want to use only some dimension, you cannot get a good result. If you want to use all dimension, it's also a problem with your computer or with the algorithms. So it is very challenging in this one. So that's why there are more research is needed to strike a balance between efficiency and the power of the presentations. That's why in the multimedia database, if you do it like deep learning, you need to have a good computer like GPU, okay? The graphical processing unit. It is intentionally for graphic, for image, for multimedia database. Okay, that's just the brief idea about the multimedia database. So hopefully you have some understanding how if you want to extend it to do the data mining on the image database. So the last chapter that I want to explain is about the basic deep learning. In this chapter, I cannot explain all the things, but hopefully you have the sense of the deep learning. And yeah, I know some of you, some of the teams already create the deep learning. Okay. So it is good, but let me give you some introduction for the student who have no understanding about the deep learning. And this is just a very basic concept that we will learn about the deep learning, and we will learn about the deep neural network, and we will just look at the CNN and the RNN, convolutional neural network and recurrent neural network, and what is the performance measures for this one. And at the end of this chapter, I will just give you some kind of trend of the data mining to give you some more ideas what can you extend if you finish from this class. So what is deep learning? When you learn the neural network, so it is correlated with deep learning. The deep learning means using a neural network with several layers of nodes between input and output. So the series of layers between input and output to feature identification and processing in a series of stages, just as our brains seem to. So there are good algorithms for learning the weight in networks with one hidden layer. Okay, so this is one hidden layer. We call it, this is the input. We call it, this is the output. However, these algorithms are not good at learning the weights for networks with more hidden layers. So if the algorithm is good for the one hidden layer, it is difficult to get to learn many weights for more hidden layers. I think there was a question from one student at the time, I think Kim Chan, yeah, you asked me, what is the good number of hidden layers? So there is no specific criteria for number of the hidden layers. So whenever you do with the multi-layer neural networks, so you will do step by step. Train this layer first, and then this layer, and then this layer, and then this layer, and finally the last layer. So what you did on the quiz is only the neural network with one hidden layer. So if you have multiple layers like this one, then you need to calculate one by one for every layer. And sometimes, okay, there are some ways to make the hidden layer, okay, or we call it, this is the autoencoder, where each of the non-output layer is trained and it will be an autoencoder. So basically it is forced to learn good features that describe what comes from the previous layer. So if we have this autoencoder, then we will check, okay, after we have this result, we will find what is the good features, and then yeah, we will do the next calculation. We will check what is the good features, and then we can do the next, and so on until the end. The intermediate layers, okay, we call it the intermediate layer, this one, are each trained to be autoencoders or similar. So we got the autoencoders. It is to make the values automatically encoded into some values. And the final layers train to predict the class based on the outputs from the previous layer. So if we have already this output, so we can use this output as the prediction. Right. And suddenly the mic. Okay, I will not use the mic. Okay. So if you learn from the graph, okay, we can see that the step is from the input until the output. Okay. So the basic concept Deep learning is also learn the data like other machine learning algorithms, but it is using neural networks. So we call it the artificial neural network. So sometimes you can see in the literatures, it is mentioned as A and N. Okay? Not only the neural network, but they mention as artificial neural network. Or sometimes, yeah, you can see it as the multilayer perceptron. So the multilayer perceptron means the deep neural networks. If it is more than one hidden layer, we call it deep. Or sometimes people say just more than two, or some people say more than 3 layers. Yeah. But as long as it is more than one, I can say that it is deep neural networks. Convolutional neural network. It is another architecture of the neural network. And recurrent neural networks. And there are many libraries. Yeah, so I guess some of you already use it for your team project. You can use the TensorFlow. It is written by Google. Keras, it is running on top of the TensorFlow. And this is generated also by the Microsoft Cognitive Toolkit. PyTorch, it's written by Facebook. So when we use the deep neural network or the multilayer perceptron, the concept of multiple layers in neural network is often called as multilayer perceptron. Multi means many. We have many layers. Since the number of multi-layer are undecidable in many works, so the deep neural network becomes common terms. We do not know how many layers is good. 2, 3, 4, 5. So it really depends on the data. It really depends on your decision. So that's why many people just use the word deep neural network. The development of the network triggered the generation of neural network such as CNN or convolutional neural network and the recurrent neural network or RNN. The convolutional neural network, CNN, it is the foundation of most computer vision technology. Whenever we use the CNN, it is good for image. It is good for the multimedia. So the basic building blocks of CNN are the convolutional layer, and then pooling layer, fully connected layer, and the activation layer. So for example, we have this image. Okay, so this is the input. So whenever I have this image, I need to make some parts of this image, as you already learned from the pre-with operators. So we will make this section and we will check what is the pixel. And then we will move to the next. What is the pixel? And we will move to the next. What is the pixel? And so on. Okay. And after we have all the pixel, maybe 3 multiplied by 3 or 5 multiplied by 5 and etc., we can do the convolution. So what is convolution? We will see later. And then after we have the convolution, we want to pull. Okay, we want to check the pull, and then after we have the pull until some size, then we can connect it before we do the prediction. So convolutional layer. What is convolutional layer? The convolutional layer use filters that perform convolution operations as it is scanning the input with respect to its dimension. So its hyperparameters include the filter size f and the stride s. The resulting output O is called feature map or activation map. Yeah, as far as I know, this is GIF, but it is not moving. Oh, okay. So as I already teach you before with the pre-width kernel, so the idea of the convolutional is using the same idea. We want to filter the size. Let's say I want to filter 3 multiplied by 3. So after I filter, and then I also define the stride. Stride means if the stride is 1, then I will move this one 1. If I have another, if the stride is, because I define 1, I will go 1. I will go 1. If the stride is 2, then I will move 2 cells. If the stride is 3, then I will start from here and I will move 3. Okay? So it depends on the definition. But usually people just use the stride equals to 1. So the convolutional layer is a filter, sometimes called a kernel. So one kernel that you already learned before, it is the pre-width kernel. Okay. It is passed over the image, viewing a few pixels at a time. You can define this one, whether it is 3 multiplied by 3 or 5 multiplied by 5 and etc. The convolutional operation is a dot product of the original pixel values with the weight defined in the filter. So you already learned with the pre-width. Okay, so pre-width is one of the filter. And then the results are summed up into one number that represent all the pixels the filter observes. So using the pre-width, you know that we have the gx, and then we have the gy, and then we do the summation, and the numbers is saved here. So we will have the smaller matrix. So this, we call it as the convolutional layer. The convolutional layer, usually it reduces the size. If we have the size as this one 6 multiplied by 6, okay, then it can be reduced to, for example, this one is 4 multiplied by 4, and so on. The pooling layer. The pooling layer is the downsampling operation. Downsampling operation means we want to check only the important numbers or the important features. It is typically applied after a convolution layer which does some spatial invariance. A filter is passed over the results of the previous layer and select one number out of each group of the values. So typically the maximum, this is we call as the maximum pooling or max pooling. So this allows the network to train much faster focusing on the most important information in each feature of the image. In particular, max pooling, average pooling are special kinds of pooling where the maximum and the average value is taken respectively. So what does it mean? Oh. So let's say I have this matrix. Okay. So I have the matrix and I already defined that the pooling layer, if I want to get the max pooling means I want to get the maximum. Let's say I have a matrix 3 multiplied by 3, okay, 2, 4, 7, 5, 9, 8, 2, 4, 3. Okay, so I have this matrix and I want to use max pooling. Then I will find the maximum value from this matrix. The maximum value will be 9. Then I will use this 9 and I will put it into a new matrix. If I reduce it to 3 multiplied by 3, if I reduce it to 1, then yeah, I will just use this one for the next operation. This is the max pooling. What about the average pooling? The average pooling, if I have those number, then I will do the average. 2 plus 4 plus 7 plus 5 plus 9 plus 8 plus 2 plus 4 plus 3 divided by 9. Then we get a value and that new value will be saved into this one. Okay. So we say that this is the downsampling operation. And after we have the convolutional layer, after we have the pooling layer, the final one, we call it the fully connected layer. The fully connected layer, FC, it operates on a flattened input where each input is connected to all neurons. So if we have like this matrix, we will make it into flattened. If you use the Python, you will see the function flatten. It means whenever you have this kind of array or this kind of matrix, whenever you have this kind of matrix, it will make, you can make it as flattened with this kind of factor. So for example, if I have the number like 2, 4, 5, 6, 9, 8, for example, 3, 4, 6. So this is 3 multiplied by 3 matrix. Then I can make it as a flatten. So the result will be 2, 4, 5, 6, 8, 4, 8, 3, 4, 6, something like this one. And after this one is flattened, yeah, we call this is the, each of this one will be connected to another neuron. And the neuron, yeah. So if present, the FC or the fully connected layer are usually found towards the end of the CNN architecture and can be used to optimize the objectives such as the class scores. So if we have this one, the neurons, then it will go to the output. So usually the fully connected layer is used to measure the class scores. The fully connected layer is the traditional multi-layer perceptron structure. So it means if you use the multi-layer perceptron, or if you use the DMN, the deep neural network, the FC, or the fully connected, is the same with that one. Its input is one-dimensional vector. So this is one-dimensional vector representing the output of the previous layers. Its output is a list of probability for different possible labels attached to the image. So if you have like dog, cat, and bird, so the result will be a kind of probability. For example, I have dog, cat, and bird. The result from the classification might be something like this one is 0.3, 0.7, for example. This is 0.2, 0.1. Then using this probability, I can make sure that this is more about dog. So the label that receives the highest probability is the classification decision. So the result will be this kind of probability with the CNN. So the problem, whenever we use the neural network, we always need to consider the activation function. As more layers using certain activation function are added to neural networks, the gradient of the loss function approaches zero, so making the network hard to train. So if it is going to be zero, because 0 multiplied by 0, then 0. So the network will not be good. So we need to avoid that one. We call those one as the vanishing gradient problem. So if it is going to be 0, then you cannot get the result. Because this is the vanishing gradient problems. It limits the development of DNN with classically popular activation function. So the classical popular function, actually the hyperbolic tangent. So nowadays there are many activation function. So how to fix a DNN multi-layer perceptron for classification? We can use the rectifier linear unit and the hyperbolic tangent with initialization. So this is the most common approach. The activation layer. The activation layer is the convolutional layer, generates a matrix that is much smaller in size than the original image. So this matrix is run through an activation layer, which introduces the non-linearity to allow the network to train itself via back propagation. So if you still remember the neural network that we learned using the back propagation. So if we want to train the network using the back propagation, we need to handle the activation with the non-linearity. So the necessity of using the activation layer. Oh, sorry, I think this one is similar with the one that I explained before. Similar with this one. Sorry, it is repeated. So there are several types of activation function. Sigmoid. I think you already learned this one. Okay. We have the tan, hyperbolic tangent. We have ReLU, rectifier linear unit, and some other variants. Let me show you a little bit about this. So if it is the sigmoid function, the result will be something like this one. You just know the formula. Okay. Last time when you do the quiz, you use this formula. The range value is between 0 and 1. So this is 0 and this is going to 1. We call it, this is monotonic, and it is differentiable, and the derivative is not monotonic. So using this number, using this sigmoid function or the logistic function, we can avoid the 0. There's another activation function, the hyperbolic tangent. The hyperbolic tangent, it shows the range between -1 to 1. And this is the formula. It is the same with the sigmoid function. It is monotonic, differentiable, and then the derivative is not monotonic. Yeah. The result is similar to the sigmoid function, but the range is different. The range of the hyperbolic tangent, it is from -1 to 1. So some of the data, if you require to have the value with minus, then yeah, you can use the hyperbolic tangent. But if it is a positive value, you do not want to have a negative value, then yeah, you can use the sigmoid function. And the other most common approach is the ReLU, the rectifier linear unit. The value is between 0 until infinite. So it means it will not reach 0, but it can be any value which is higher than 0. So it is monotonic, and then it is differentiable everywhere except where x equal to 0, and the derivative is monotonic. So if you use Python, I think you do not need to calculate by hand. Okay, so the Python will give you just the parameter, what kind of activation function you want to use. If you use the sigmoid function, then it will directly use this formula. If you use the hyperbolic tangent, they will just apply this one. If you use the ReLU, they will apply this one. Yeah, so this is the general architecture of the CNN. Let's say I want to predict the zebra. So I will use the kernel. So the kernel is the one that you learned before. And then you will do the convolution. And for every layer, you need to define the activation function. The first convolution, let's say I use ReLU. And then I will do the pulling or downsampling. And I will do the convolution again with the activation function, ReLU. I will do the downsampling with pulling. You can choose max pulling or average pulling. And then you will do the convolution again with the ReLU until in some part you can flatten it. And after you flatten, you can make the fully connected layer. So this part might be similar with the DNN. And you will get the output. If it is, maybe the end of this one, you will still have the activation function before you get the probability. So if it is horse, maybe this is 0.2, zebra is 0.7, dog is 0.1, then Okay, I know that this is the class of J-block. So, and if you do with the machine learning, you need to check the feature extraction. But with the deep neural network like this one, you do not need to extract the features. Okay, I will stop here. Any questions, comments?